Hey, what's up everybody? In this video tutorial, we are going to be taking a look at how to create a parametric eccentric cam. In order to do this, you're going to need this cam dimension drawing reference sheet in front of you. And when we take a look at this, you're going to see this isn't like any sort of reference sheet or working drawing that we've seen before. We're seeing letters and we're seeing fractions and seeing true measurements. It's a little bit different. And we kind of take a look and investigate these a little bit more, even on the other three cams, you're going to see basically that it's it's kind of outlining references of variables in this case. And we have to set up variables because we want things to be able to change, and we can get things to change easily in Inventor using something called parameters. So make sure you have this in front of you. We're going to be using this sheet that we see right here when I'm going through this video tutorial. So I'm going to go ahead and just move that to the other side. And then I am right now in a standard inch IPT. So I have one of those open. And let's go ahead and let's get started. So the first thing I'm going to do is I'm going to come up here, go to Manage tab, and you're going to see the parameters box or panel is right up here. It has the big FX. You can't miss it. Let's just go ahead and pick on that parameters box. Okay, the parameters dialog box is going to go ahead and load up. And we can see that there are two different types of parameters that we have available to us. We have model parameters and we have user parameters. These are the ones that we can define ourselves. Okay, so when we're looking at our dimension drawing sheet, you're going to see that we're going to need to set up a parameter for the diameter. We're going to have to set up a parameter for the actual hole size. And then what I'm going to add is going to be thickness for the actual cam. So I'm going to come down here and pick on add numeric. And I'm just going to type in a parameter name like DIA, which stands for diameter. I'm going to go ahead and just put in what that equation is. So I'm going to say in my case, we're going to go ahead and just put in a static number of 1.5 right now. This is something we can change later on. Okay, I'm going to add my second parameter, and this one is going to be hole. And the dimension I'm going to use for my hole is 0.25. All right, so 0.25 diameter is what we're going to use for the hole. And then I'm going to add a third numeric, and that one is going to be THK, which stands for thickness. And the thickness in our case, our plywood thickness is 0.1875. So once again, our diameter loaded right now is 1.5. Our hole has a diameter of 0.25, and our thickness is 0.1875, okay, for our plywood thickness. I'm going to go ahead and hit done. All right, and now we can go over to the 3D modeling environment, start a sketch, pick on a plane, does not matter which one it is, and I'm going to go ahead and just create my first circle. So I'm going to start here from the origin, okay, and I'm going to bring this circle out. All right, so instead of actually typing in an actual number, what we can do right now is just type in DIA. That's going to be the diameter of our actual cam. All right, and we can see how it's referencing FX. Okay, it's referencing the parameter that we set up earlier, and that value for DIA was 1.5. So we can see that working for us. Now I'm going to go create a circle. I'm just going to track this off the center point, pull this straight down. I'm going to draw this circle right here. In this case, I'm going to go ahead and just type in hole and hit enter. All right, just to make sure that's exactly where it needs to be, I'm going to be coming up here, going to my vertical constraint, picking on the center point of my large cam and the center point of my hole, and making sure that those are vertically aligned. Okay, and we've just done that. So when looking at my dimension drawing reference sheet, it is saying that the dimension from the center point of our cam to the center point of our hole is going to be DIA times 0.25. Okay, it's going to be quarter of the diameter all the time. And we can see how that slides right into place, and we're good to go. All right, so we're done with this. I'm going to go ahead and finish up with that sketch. I'm going to go ahead and do a little zoom extents here, and now I'm going to come out and do an extrude. Now, whenever we are doing cams, something that's going to be helping us later on is that when we go to do our extrude, we're going to do a symmetrical extrusion. We want this to happen right here in the center because later on we can turn on a work plane. It's going to go right down through the center of that cam, and that's going to be a huge helpful thing later on. All right, so just don't forget to do your symmetrical. Now for my distance on this one, I'm going to type in THK, and that is going to be reading the parameter that we set up earlier for thickness. I'm going to go ahead and say OK on that. All right, and there we go. We have our cam created. All right, this time point in time, that's when we can go ahead and apply our materials to it and whatever. But let's just go ahead and let's just actually see if this is going to work. All right, so outline in the actual project, eccentric cam could come in 1.5, 2, and 3-inch diameter sizes. So let's go and let's just actually try this out. I'm gonna go ahead and just scoot this to the right. Okay, I'm gonna go to manage. I'm gonna pick on parameters, and all I have to do to change this from a 1.5 to a 2-inch diameter is just come in here to 1.5, type in 2, hit enter, and now we can see how that grows here on the right hand side. Okay, 2, 3, we can see how that grows. Now what's cool is that we can also see that the dimension, okay, from the center point of the cam to the center point of the hole, all right, that's also changing because it's referencing the actual diameter parameter that we set up. All right, the hole itself is going to remain static because that was locked in at a diameter of 0.25, and the thickness is locked in at our THK parameter, which is 0.1875. So this is how you can quickly create smart parts, for your project. You could even go below this. Let's just go down to 3/4. Let's see what that looks like. All right, so we could easily come up with whatever it is we sort of need to do. All right, now if you need to create a library of parts real quick, all right, this is a 1.5-inch eccentric cam. We can come up here to a file, save as, okay, and we could just give this a name of like eccentric cam 1.5, and that'd be a 1.5. Okay, and then we could jump over into parameters, change this up to a 2-inch. Okay, and then we could do a save as. All right, and I could come out here and say this is the eccentric cam 2.0. We know that's a 2-inch. And if we want to do this one more time, go to manage, parameters, 3-inch. Okay, and we could do a save as. So just that fast, we've made some really smart parts. Okay, um, those are the default settings for all those cams that we have within the project. Maybe you want something outside of it for another project. You could easily do that with parametrics, just like we did. So there you go. That's how you create a parametric eccentric cam for the Pull Toy project.